So here we can measure time, we can set the date, we know the day of the week, but our sun doesn't go up and down. It doesn't set and doesn't rise. So we should actually make that happen. And here's how. It's gonna work regardless of whether you have my type of calendar system or other. If you have access to how many minutes or hours have passed, then you can make this. So it's gonna be really easy, but just in case you wanna follow along perfectly, I will make the link of the video appear either in the description or a card up in the top right corner. So yeah, let's start. For our sun cycle, we are going to create a blueprint, which is going to be an actor blueprint, and we are just going to call it like sun. We're just going to call it sun cycle. And we open up the blueprint. We do not need anything in the viewport. Of course, we can delete the overlap event. And one thing we are going to want is to actually sequence right in front of the begin play, because we are going to have to reference a few things from our level, or not exactly from our level, but we are going to need a few stuff, and one of that is going to be the sun. This is going to be this directional light, so we are going to need to find that from our blueprint, and the way we are going to do that is very simple. We are going to get actor of class. Our class is going to be directional light. And once we have that, this is going to get the first actor that has the light, has the class directional light. And we just have to promote that to a variable, and we are going to call it sun, because the first directional light it's going to find is going to be our sun. Your project might be a bit different. You can get all actors of class, or get actors of class with tag, and then you could tag your directional light acting as the sun. One thing that's very important is, I think it is by default, but if you go down here, it has to be set to movable, your sun. So I think I can comment this out to be sun. Perfect. Now what we are gonna have to do is create a custom event, and I'm just gonna call it update sun location. Or actually, it's gonna be rotation. And from there, we are basically, based on the time that has elapsed, essentially, we are going to calculate where our sun is. So I'm actually going to move this down. Bad. And we are going to have to create a reference for our calendar as well. So we are going to copy this logic up here and connect this up. And this is going to be our calendar, because our calendar system has the information of how much time has passed by. And we are going to do the same thing here. We are going to promote this to a variable and just call it calendar. Just like that. Now that we have our calendar, we can just drag it into our scene. And I want to update the sun rotation by the minute, so I'm going to get the minutes that have passed. These are variables that I have in my calendar blueprint. So if you don't have it by this name, then obviously use the ones that you have. And I'm gonna get the hours. And actually, let's put them on top. And I'm just gonna do a quick multiplication so that I get the hour values by minutes. And I'm actually gonna add these two together, and now we actually have a total of how many minutes have passed in that given day. And what we can do with that is, since I am using like the Gregorian calendar and our current time formats, I know that there is 1,440 minutes in a day. So if I just create a quick division and I divide this by all the minutes in a day, I get a fraction between 0 and 1, that will tell me which part of the day it is. And if I just multiply that by 360, I already have, my bad, 360. I already have a very basic day and night cycle. So if I just make a rotator here, and just plug it into the Y, and actually this division has to return a float because it's between 0 and 1. So let's do it that way. Double plus precision, and actually let's recreate this then, because yeah, it's doing it silly. So yeah, my bad. Make sure you have floats, because the integer would just round it to 0 or 1, and that's not good for us. So we make a rotator, and we are gonna set the world rotation of our sun. Essentially, we are gonna delete the default scene root, and we have set our sun, so we can just get our sun and plug it in. It's gonna create the root component for it, the node itself, and just plug in this rotation. And what we have now is 12-hour day and 12-hour night cycles. If I just connect it up and go into my level, and we have our sun cycle blueprint, and I just drag it in, it's not working. Oh, we did not update the sun rotation. So we have to call it on the tick. And now it's gonna start at midnight because the default settings. You can see it's very dark. We are gonna fix that. We are gonna add moonlight that rotates opposite of the sun. But okay, let's speed this up. And the sun rises at 12 o'clock. So we have a cycle that works, but I actually want to control how long is the day, how long is the night, when does the sun set, when does it come up. So I think we're gonna go with 16-hour daytime and obviously 8-hour night. And we are gonna offset it by a little bit so that, you know, we can control when it happens. So back in our blueprint, we are gonna separate the logics a little bit, not by too much. We are not gonna need these, and we are gonna make 2 rotators. Oh, my bad. And one is gonna be for the daytime and one is gonna be for the nighttime. We are gonna create 2 new variables. One is gonna be an offset and one is gonna be a day length, essentially how long I want the day to be. So it's gonna be length of the day. I'm just gonna make it an integer, not to overcomplicate things, and another is gonna be offset by hour. And what that one is gonna do is I'm gonna make both of them public. And what those 2 are gonna do is the offset by hour is we can put in an hour and it's gonna offset the rotation by as many degrees as it would move in said hours. So first, for the length of the day, we are gonna use this to make sure that our night is as long as we want, and our day, of course. And the way we are gonna do that is we are gonna calculate the total of minutes in a day, essentially, and that's not gonna be too hard. So since we are gonna give it in hours, we are just gonna multiply it by 60 to get the minutes of this. So far, so good. And that's gonna be our day's length in minute. And to actually get the night's length, and I usually work with the night's length, we are just gonna subtract it from 24 real quick. So subtract and move this to the bottom, and we subtract it from 24, and That way we have the length of our night, and duplicate this node real quick and just plug it in. So we have the night's length and the day's length in minutes. Very good. Now, to actually make calculations for this rotation, it's not going to be super difficult. We are going to create a branch first and foremost, because we want to decide if we want to use the days or the night's rotation, because the way we are going to go about this is we are going to make a 180-degree turn in the given time that we have given the length of the day, and then the rest of the 180 turn is going to make sure to happen in the night. It's not exactly geographically accurate, so if the night is shorter, that means that the moon is rotating faster and the sun during that period of time. So first I'm just going to create a quick division node here, or divide node here, and what we are going to divide is the day's length goes to the second input, and this one, the total, is going to go into the top input. And this is the exact same logic we had before, only we are going to multiply it by 180 instead of 360. And then we have the night's rotation. And actually this very much has to be a float because of the same reasons as before. So before the multiplication, it has to be a float. And we actually are going to add one more little thing, and that's going to be an addition. And what we're going to add is we are going to multiply the offset by 15. Because for every hour, we should move 15 degrees. That's simple calculation. You can make this dynamic. If you have like 30-hour days, then this number would obviously be different. And we are just going to add it to that one. And we can just plug it into the Y, and our night is going to be exactly as long as the length of the day leaves us from 24. And we are going to do a very similar logic for the day's length. And since I usually base my stuff around the night, we are going to calculate that from the night's values as well. So first things first, we are going to have to subtract from this. And what we are going to have to subtract is, my bad, no, this gets subtracted from this actually. And then the exact same logic. So we are going to do a division here, just like this. And we are going to divide this by the day's length. And now we have basically this logic. We are just going to copy and paste these. And this one has to be a float yet again. And just plug this in, times it by 180. And we are going to add our offset to this as well. And this can go into the Y. And now we have a day and night's rotation, and let's actually give some default values here. So for the length of the day, I think 16 is really good because it gives you more daytime. It still feels natural, and we have 8 hours of night. And yeah, I actually left out one slight little problem, is we actually have to add 180 to the day, because obviously the second part of the rotation happens after the first one, so and it's a 360-degree rotation, so it actually has to be added to it. So yeah, that was my bad. Oh, yeah, we actually left out the condition for this, and yeah, that was silly of me. I just completed the logic, but what we actually have to check if like the total minutes elapsed should be less than the length of the night. And that's our whole condition, and I left that out. Minutes elapsed. And now the sun should come up at around 8 o'clock in the morning and it should set at midnight. Then we are going to add an offset to it just to see if this works. Comes up at 8. And it should set at midnight. And it's perfect. Let's add actually a 2-hour offset so it comes up at around 6 a.m. Okay, perfect. Now, let's actually do something about how incredibly dark the night is. And what we can do to make it a little bit better is we are going to add a directional light into our scene. And I'm going to call this directional light the moon. Now the moon, my bad. Now the moon, I want to add a tag to it so we can find it easier. And this is going to be an actor tag. And I'm just going to call it moon for simplicity's sake. Now that's the first thing we need to do. And I actually want to add the night sky. And this is going to be like this. So we drag a sky sphere into here. And I'm going to set the location of it to very much 0 in every sense. Like that. And the scale is going to be 399. The original is 400. I want it very little bit smaller. And we are going to actually, we have this warning here, so we are going to set some priorities here. Yeah, this is going to be 2. The first size sky sphere is more important. So we have our tag, we have our priority, and I'm just going to call it night sky. Now, the material for it is going to be created from this image that I found on the internet. You can, of course, create your own night sky, which looks best. I just found it on the internet. We are gonna, well, I've actually already created the material. We just have the image as a texture sample. We connect it to base color, which is not exactly necessary. You can connect it to emissive color. Then we desaturate it and use it as an opacity mask, essentially, or opacity. And we are gonna multiply this by an opacity scalar parameter. Just hold down S and click and call it opacity. And remember what you name it. Okay, set the default or leave the default as 0 and multiply it together. Multiply is M and click. So hold down M and click. So connect it up like this. And you can save it like that. I'm just gonna close these out. And for our night sky, which we just dragged into the level, we are gonna set this as the material. So yeah, tutorial sky material, and just set it like that. And since the opacity is 0, we cannot really see it. Now, if you don't have this sky sphere, this comes with the engine by default. So you can just go into all and search for sm_sky sphere. And there you have it. I just create, not this one, engine sky. I just created a copy of it. So I'm not messing with this one directly. I have just created a copy into my own folder right here. So this is the copy of it. Okay, so I'm pretty sure I've already set the priority. Oh, it had to be for the directional light. My bad. Sorry. Like that. Now we have our night sky and our moon set up. So we can go back into our blueprints in the sun cycle. I can close this one, sorry. So we are gonna basically change the opacity value. And the way we are gonna do that is we are gonna need some references. And actually, we also are gonna give a tag to our night sky. So we're just gonna tag it. And actor tag. So under actor tags, I'm just gonna call this one night sky. I'm gonna copy this too actually. And now go back into our blueprint. I'm gonna add 2 more pins here, and let's get all actors of class with tag. And the class is gonna be for the moon, it's gonna be a directional light. And the tag is gonna be moon, because that's what we gave it. And it's case sensitive, so make sure you remember it well. And we are gonna use a get here, and we are gonna get a copy of this. We are gonna get the first element, which is the 0 index, and we are gonna set this as my bad, we are just gonna promote this to a variable, and I am gonna call it moon. It's gonna be that simple, and it's gonna be by the type of directional light. So comment this out. It's gonna be moon. And let's move this up a smidge. And now we are gonna add our sky sphere, and actually just duplicate this, Control D. And this is gonna be a static mesh actor with the tag night sky. It's better to just copy paste it so that you don't make any mistakes, but I'm gonna take my chances. We are gonna use a get. We are gonna get a copy. We are gonna be fine with the first since we are looking with a tag, and we are gonna promote this to a variable. And this is gonna be the night sky. Very nice. And the first thing I'm gonna do is actually just add a good looking night sky, and we are gonna fade the opacity. Now, the way we can do that, it's not overly difficult. So we are gonna get our night sky here, just drag it in. The types are already good because we have used the all actors. And we are gonna get, well, the static mesh component actually. And we are gonna set the material scalar parameter. Actually set scalar parameter value on materials. Perfect. And actually it has to be separate for both of the logics. If we just leave it like this, so we can just say that, okay, this is the daytime, so I want it to be 0. This is the nighttime, I want it to be 1. That's fine. Actually connect this up. That's fine, but it looks better if we fade it a little bit. So it needs a value from 0 to 1, and one value goes from -90 to 90, and the other one goes from 90 to 360. Or, well, it's similar to that, I'm not exactly sure, but we have a 180-degree angle that we have to calculate from. So for the daytime logic, I'm just gonna go very simple. It's not gonna be an exact math because I want to give it a bit of a buffer zone. It doesn't matter if it goes above 1 or below 0. And since I don't want the fade to be gradual throughout the whole day, and I just want it to be in the last few hours of the night and the first few hours of the day, we are gonna, well, handle it that way. So essentially for the daytime, we are just gonna drag out from here. And we are gonna divide. And we are gonna divide it by -90. No, actually, we are gonna divide it by 90. So if it goes from -90 to 90, we are gonna get a value from -1 to 1. And then we are gonna actually divide it by 2, because when I tested it, this worked best for me. So you can try your own values, you can do the math yourself, and we are gonna subtract 2 from it for the daytime. And this will give us enough buffer when the value moves so that it only works in the last few hours of the day. So the stars fade in as the sky goes dark. And for the top one, it's gonna be very simple as well. And actually I made a mistake here because I am working from the night sky actually. So connected to the top one. because I calculate all the stuff from the night's variables, because this whole thing is dependent on the night and not the day. Okay, so to actually fade out the night sky, we are gonna do something very similar. So I'm just gonna copy this as well and paste this here and connect this up like that. But we are actually gonna divide by -90. And the division by 2 is gonna stay the same, but we are actually just gonna add a bit more than 1 here. And that's gonna look good. And connect this up. And let's actually add the moon so it doesn't go as dark as it usually does. And that's gonna be extremely, extremely simple. So we are just gonna duplicate the make rotator and the set world rotation. And we are gonna use the same values as we did for the sun, but we are just gonna add 180 to it. So how that works is, here's the rotation value with the offset, and we are just gonna add 180 and plug this into the Y. So let's actually duplicate that there, into the Y, and into this one. And now we should have our logic. One more thing real quick, we actually have to connect our moon, which we have saved. So we do not rotate the sun again, only the moon. Get the moon and, oh, sorry, right there. And one slight modification I do want to make is, if we go into the moon, I do want to decrease its intensity by a fair amount. So like 1.5 should be good. And I want the color to be kind of bluish. The moonlight should be bluer, I believe. Like that. I think that should be good. Let's test it out. We can very well see in the night. We don't have the sky sphere, so we might have to fix that real quick. But let's see if the sun comes up at around 8. Okay, that seems fine. Sun goes down. The opacity of the night sky does not change. Okay, that's worrisome, but I think... Oh, okay. So, for one, we have to set the directional light of the moon to be movable, which we can just select it and set it to movable. That's fine. And we should see the moonlight move. That's perfect. Okay, let's actually fix the night sky. Oh, we did not actually change. We did not connect the execution pad pins. But I think with this, we kind of should be. We never changed it from 0 to 1. Only from 1 to 0, which, yeah. Okay, that's still worrying. So let's see where the problem could be. We did not set the parameter name. That's actually... So this parameter name has to be the same as this one, right? It's opacity, so set opacity. We were setting exactly nothing. So now, I do believe we are A-okay. So let's see. Yep, we do have our beautiful night sky. Let's see how it fades in and fades out. Matter of moments for the fade out. Let's see. Okay, looks very nice. Let's see if it fades in properly. Oh yeah, it started to fade in already. Oh, it just wasn't looking correctly. Gets stronger, 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 and strongest. Very nice. I'm very happy with that. So yeah, that's it. That's a sun and night cycle. We can control the length of the day, we can control offset, we can control everything we want. I think it looks very nice and it's very flexible. You can change a lot of things in this, and it works with any kind of calendar system and everything else. So I really hope you enjoyed that. If you did, and if you learned something new, please consider subscribing. It helps me out a ton. And yeah, see you next time. In the next video, we are going to talk about how to control seasons with our calendar and how to actually change the environment with the seasons changing. So I'm going to show you quite a few examples of what to do. The blueprint's going to be super easy, so most of the time we are just going to worry about how to actually change parts of the environment and do snow build up in winter and stuff. So yeah, see you next time.